Hi, welcome back to another video. The program I'm going to release in the show more for this video reads a 2 gig card formatted with FAT16 and a 4 gig card, 16 gig card and 32 gig card formatted with FAT32. As discussed in my previous video, my very last video, the boot sector or sector 0 on these two 16 and 32 gig cards, sector 0 did not contain the volume boot record, and I found no information on the internet to tell me why, and no information on the internet to tell me how to go and find the volume boot record from those numbers I showed you the other day. This program does it all for you. I'll put in all the cards, but at the moment this program only shows the pictures on the high capacity 4 gig, 16 and 32. Now, I dismissed this A data the other day, just figured it was a cheap one. This seems to outperform the Samsung in the sense that it's less fussy with how I write the data via SPI. However, you do need to slow the process down, otherwise you get 512 bytes of 255, which is like a white line on here. The Samsung is exceptionally fussy. Now, the Samsung, as I explained the other day, is from my dash cam, so it works really well recording 2 lots of data from 2 cameras in HD. So it's a very capable card, but doesn't like being repeatedly hit with read sector as I'm doing with this program. And if you're not familiar, these SD cards have 4 data lanes, so I'm guessing in the dash cam it implements the 4 lanes, whereas I haven't got 4-lane data, I've just got SPI, so I'm just using 1 lane of data. I've got a number down here. The only important thing in the program, have a look at the C file you see, I'll give you a quick flash of it on the screen. When you tell command 17 what sector you want to read, if you keep on sending data to that very quickly, this Samsung is prone to throw an error. So to stop the possibility of errors, I've put in a delay. It's actually using a for loop, so you can change it at will. And I'll demonstrate that on here. These two 2 gig cards will work with a really fast clock, up near sort of 16-18 megahertz. Without a problem, and you don't have to have much of a delay. Same with this 4 gig card, don't need much of a delay. These larger cards, you need a delay. So subsequently they're slower at reading pictures. I've not yet learnt how to use the multi-sector read, because as I've demonstrated in a previous video, it doesn't matter how long it takes to read a picture from the SD card, I can read it over a period of minutes if I like. I'll put it into SRAM and then display it in 0.2 of a second later. I've already done a video on that. Let me give you a demo. I'll start with the 2 gigs. I've got some delays on there so you can see the information. Right, 2 gig card first. Right, so it's not going to show the picture, but this is a 2 gig card, FAT16, and there's the files. And as discussed the other day, that's the offset. So it doesn't read it anymore, so I can take it out. The other 2 gig card. There we go. So JB card 1A, there's a transcend. The offset's 4 on that one. It just demonstrates this program, as I say, which I'm going to put in a link in the show more on GitHub. Will read FAT16 and FAT32. Now, if you've seen my previous video, this 4 gig HC is a very fast card, probably one of my best here actually. Sector 0 did contain the volume boot record. These other 2 here did not, being high capacity FAT32. You can't have high capacity and FAT16. There we go, so offset of 1, high capacity card, FAT32, picture size sectors to read, and that's the picture. And there was a for loop of 10,000. Well, this A data, which I believe, after all the tests I've done, is actually a good card. Doesn't throw up errors, you just get white lines if you try and read it too fast. So now you'll see longer delays here. Root directory, offset of 1, cherry bitmap 16 gig, picture size, remaining bytes to read. So you can see this is a lot slower. And the for loop, which you can find in the C file, is set to 25,000. I can reduce that down to 5 or 10,000, and if I reprogram this board without turning it off, it will read that picture very quickly. But this A data card, you'll get white streaks where you've tried to read the data too quickly. The Samsung will start throwing errors. So what's the point of trying to read it quickly if you start getting red screens showing an error? So that was the A data. After testing this card, I think it's a good card. I thought this was going to be the best card, but this is the fussiest using SPI. So to be fair to the card, yeah, I'm using SPI, not 4-lane data. Right, Samsung. Large number of sectors. So this is a dashcam SD card. Well, so you can see this is quite slow, but it's reliable. So the for loop delay started at 25,000. If there was just one hiccup in reading that command 1,501 times, this would have increased by 10,000. So let me show you. Let me reduce this delay and I'll show you what the problem is. Right, I've set the delay to 10,000. So this is the Samsung card. Right, so you saw that was faster, and our delay here still 10,000, so there were no hiccups just now. Now watch this. Unplug it and restart it. I'm pleased that happened because I thought, don't tell me it's going to work. That's what happens. If the board has been turned on and you keep on attacking the command 17 with short delays, there's no problem at all. But this will throw this red screen and tell me where the error is if it encounters that error more than 5 times. So what's the point of trying to get a picture quickly if it's prone to errors? So I just put a long delay in. Well, so I've just put that longer delay back on. It's a dashcam Samsung card. As I say, I thought the Samsung was going to be the best, but it's the fussiest when using SPI. There we go. So this merely demonstrates the use of SPI to read SD cards, whether it's standard capacity FAT16 or high capacity FAT32, 4 gig, 16 gig and 32 gig. As I say, I'll put a link in the show more, If you found this video helpful, don't forget to click like. If you want to use the C file and you fancy making a donation, the link is in the show more. Thanks for watching.